Okay, so what I want to do in this video is show off the system that I'm working on. It's pretty much done, actually. Um, this is an input handler written in Odin. I do all my stuff in Odin now since like 2020. It's like C, but it's just better. It's pretty much the optimal programming language. It comes with everything you would want to use. Um, I don't know why I'm including those, by the way. Anyway, so I find myself a lot of times when I write code that handles inputs in games, in general, I think you want to avoid having different layers kind of, different layers of abstraction kind of blended in together. And like, you're kind of in layer, we'll say 4, but then you've got code that deals with like layer 2 and 3 kind of interspersed in that layer 4 code, if that makes any sense at all. Basically, it's like if you're in the middle of some pretty deep part of your custom code, and then all of a sudden you're making calls to like Win32 APIs, and you have like a switch for like different operating system calls or something in the middle of a function that shouldn't really have anything to do with like being OS specific, or that should just be abstracted away from the OS level at that point, where you just make a call to some system that you built. Um, you know what I mean? Kind of like uh, having your OS specific and API specific code, dependent code that just deals with dependencies, kind of is like the leaves, and your main code should really just be its own self-contained thing, kind of the trunk of the tree, if that makes sense. And then all of your platform stuff, or like SDL stuff or raylib stuff, should kind of be its own isolated thing, in my opinion. Um, I mean, raylib you can kind of use just wherever, at least for simple stuff. But if you want it really organized, I would recommend kind of segregating it anyway. Um, so this is about 612 lines just to handle input, and that sounds kind of ridiculous, especially because we're using raylib to actually get the raw input data. And raylib kind of handles a lot for you, so you might be thinking this is ridiculous. Why do you need this much code? Um, the reason we want to do this, we basically want to figure out what the user is actually trying to do. And this is what I call an input signal, or just a signal. Um, so these are always checked for, even if we're not in a context within the game or whatever program you're making, where it would make sense. Like, let's say we're not in a place where we're in a menu, we can't move a character in the world map. So these signals, you know, aren't ever checked in that situation. It still does flag these though, and check for them. It's really cheap to run the entire function that handled all of this. It's literally 4 or 5 microseconds on my computer, which is just a laptop. I think it was like a $500 laptop from Walmart. It is a Lenovo business laptop or whatever. Anyway, it runs in 4 microseconds in release mode. But what we want to basically do is take our physical input parameters, so the current state of all the gamepads, the keyboards, the mouse, whatever, and convert it into this abstract idea of, what the user is actually trying to do. Are they trying to navigate in a menu, a UI up, down, left, right? Are they trying to confirm a UI option, like hit a button? Are they trying to back out of the menu, which is like the, I guess, circle button on the PS2, and this would be like the X button, kind of thing. So our function down here, this is input controller tick. This is the big thing that just, you run it every frame, you give it the delta time, it figures everything out as far as what the state of the controllers are, and then it sets all the state in this this big input controller struct, which just has everything that we need for handling inputs. Um, so we have these pre-made sets of input groups, which is just a bit set of input signal. If you don't know what a bit set is, it's like the thing you do in C a lot, where it's like this equals 1 shift left 0. This is 1 shift left 1, 1 shift left 2. Basically a flag set, where each bit in the value is one of these, or represents one of these. Basically like a compressed Boolean situation. We have the option to, if we want to, we can, what I call, capture this function right here, which takes out a set of signals out of the group. So it's like if you have code that handles the UI, for example, we can basically void out. We can call controller input capture with this as the argument, and it captures all the UI input. So any code after that point, that same frame, that is trying to figure out if we're doing anything with the UI, it's going to return false for all of it, even if we really did activate these UI signals on that frame, because that code's already handled it. It's done. It's captured. It's voided out for the rest of the frame, which is useful in some situations. I know like Windows has something like this for like handled versus unhandled, something like that. I don't really use the Win32 API directly, but I know I've seen something like this in a lot of input systems, and it does have use cases. Where this gets really cool is that you can set a custom bindings. So, you know, in a lot of games, you'd have to go in and go to your Steam settings and remap your controllers and whatever. It's kind of ridiculous that more games, in my opinion, don't just let you set the bindings in some menu within the game. It's really not that hard to do something like that. So this gives us the flexibility to actually do that. So we just define, this is just a default map input binding thing right here. This is just what gets set if we don't have like a save file. We don't have a preference already set up, or if we're in debug mode, it always uses this, even if there is a save file present, or not really a save file, more of like the user preferences file, but that's a whole different thing. Anyway, so we basically OR all of these conditions together every frame. So either we can press, personally, I prefer the O button on the controller, or I guess the B button on an Xbox controller to be the confirm button, and then X or whatever to be the back button. So right face down is X. This is like O. So we can either press that button on a controller, we can press enter, we can press X, or we can press the left mouse button to send a UI confirm signal. And then like if we want to go right in a menu, either we can enter the right quadrant on a left joystick on a controller. We can press the right D-pad. We can press the right arrow key on our keyboard. The difference between like UI right, by the way, and character movement right, you'll see it's enter axis range here. That's a one-time firing thing. It checks for the delta of, is the current quadrant in the right, or is the joystick in the right quadrant currently, but also was it not in the right quadrant on the last frame. So it's only when it deltas, when it changes, does this one fire for the UI, whereas the character movement, as long as you're holding right, it's always going to fire. That's what we call in axis range. So yeah. And then see, also type equals held for pressing the D-pad left, and held for the keyboard right arrow key. So that's kind of how we communicate between the physical hardware that we're dealing with and the actual game code. We really don't want to be dealing with hardware in the middle of the game code. That's what I mean with like the layer 1 stuff in the middle of your layer 3 or 4 code. It's just really weird. I don't like it. It's design problem. It's impending design problems and bugs and things like that if you go that route. In my opinion, I wrote a lot of code. I made a lot of mistakes. I've been coding for like 10 years now, and I know exactly how I mess things up and how things get spaghetti code. And yeah, I'm very, very just autistic about avoiding that now. And this code is not perfect at all. This is just like a sketch basically of how I want my input system to work. This took like 2 days to write. Like 2 full days, 12 hours to really think about all this and figure this stuff out. So this is the part here in our tick function. This read does all the raylib stuff to figure out where we are. If you're reading the quad state from our gamepad, it's not really what quadrant the stick is currently in. We do store that in the actual quad thing, this and this. We store the last one, the last frame, just because it's, for the delta stuff for entering a zone versus being in a zone. We delta from the last to the current frame. Anyway, so we just set the actual quad to what quadrant the stick is actually in. But the quad versus the actual quad, this is more of like a pseudo thing. It's weird. If we are in the dead zone, then we just set it to dead zone. But if we were in the dead zone and we've entered something that is not the dead zone, then this changes. So it only transitions between a non-dead zone state and a dead zone state. So either you have to be in the dead zone or you have to be entering the dead zone for this variable to change. Or I'm sorry, you have to be either from a non-dead zone to a dead zone, or from a dead zone to a dead zone, whatever, it stays the same. Or if you're leaving the dead zone, then it updates this, but it will not update from if you're holding the stick up and then you push the stick to the right without ever entering that neutral dead zone state again in between. It will not change. It will still be up. The reason that's useful is because that would be weird behavior for menuing specifically. Like if let's say there's a menu that's like 4x4 items, okay? And you're in like near the center. So you're on 1, 1. So if 0, 0 is the first top left element, 1, 1 is like down and to the right by 1. You press up, your new coordinate is going to be 1, 0. But if you press up by first moving the joystick to the right, now your coordinate's 2, 1. Then you move up to 2, 0. But you move up by keeping the joystick in the right position, so that's moved you to the right. But then you go ahead and just move it up, like twist it around to the up position, but you never neutral it again, and then it would move the cursor up by 1. That would be weird to me. I wouldn't like that in a game. That would feel strange. So it requires you to basically center the stick back to dead zone, back near the center, in order for it to register that. Yeah. That was a pretty long, complicated explanation, but it just makes it feel nice and give you the right UX that you want with menus and things like that. But for the character movement, we read actual quad because you can fluidly just switch and move the joystick however you want, and it will change the way the direction the characters are moving. That's normal in games, in my opinion. If you had to like release the joystick and then change direction, that would be so weird. But it makes complete sense for menus. And this is the code that actually sets our signals. So this just goes through the whole bindings list thing. And again, this only takes 4 microseconds. I'm kind of impressed that it's this fast. But it goes through all of the bindings every frame. And then it goes through every possible way that you can trigger that binding and verifies whether it needs to be triggered. So it checks whether the stick is in the quadrant, if it's an in-axis range condition, or if we're entering the axis, which is again for like UI. And then this toggle is just very simple. It just just fires the signal. It adds the signal key to our signal group for the frame, if any of these are true. And by the way, it does go ahead and clear our state at the start of this. So this hitbox stuff is something totally different. See, so this is all the pointer control logic and animating. So this is kind of how you navigate UI elements. So here I've put up 2 debug boxes. So there's hitbox to the left here, hitbox to the right here. And so I'm just pressing the left and right arrow keys, and you can see how it's triggering these UI signals, but then it's also going ahead and triggering the character movement. If I hold right, it's constantly triggering the character movement. And the joystick on the gamepad just works too. just like this, and the D-pad buttons because of the way the bindings are set up, like I showed. So, yeah, I think this is just really cool. And the logic, this took a long time to logic out. This is pretty complicated. There's a lot of variables that we're dealing with, a lot of state that needs to be, you have to keep up with in your head. It took a while to debug and get all this working. And we do abstract away. So like we read the raw actual gamepad axis positions, which is on a scale from like -1 to 1 floating. So we this is to check if it's out of the dead zone and etc. So this whole loop here, this for loop, is all just for checking gamepads. Yeah, if the gamepad's not available, we wipe everything to 0. Yeah, so pretty simple. And then the gamepad checks are just pretty easy. We go through all the gamepads that we have. If it's not available, just skip it. And yeah. And this is how we actually feed our UI stuff. So it's very minimal communication. Basically, whenever we're in the final UI loop, I do use Clay for the UI in this engine, but this doesn't have anything to do with Clay right here. This is just, you feed it a hitbox of UI elements. You set the dimensions, so 2 wide and 1 tall, and then you go ahead and set your indices, so index 0, index 1. So this one's to the left, this one's to the right, and then you just give it the hitbox of literally the X, Y, width, and height in integers of where this box is that you want to deal with, and it just handles everything for you. Like this, that's what these 2 boxes are here. And it's just animating the mouse cursor between them. It's lerping it linearly, and it handles weird edge cases. Like if you hit left and right really quick, it just works. It just goes ahead and snaps it to the box on the left, and then it starts animating it to the right. And that was me hitting left and right like 2 frames after each other. And then if you hit like right and then left, it snaps it. It goes ahead and like completes that first animation because you're overriding it basically, and then it just starts the animation to swipe it to the left box. So it handles all of these weird edge cases. You can start moving it and then move the mouse real quick, like that. And you can control all of this with just the mouse manually, by the way, too. It handles logic for all that. It has 2 different modes. It's what this pointer CTL versus button CTL. So if it's in the pointer state, but it knows that you're pressing a direction, like you pressed either a UI up, UI left, UI down, UI right signal, because see, it checks for, this is our signal check loop here. It checks for signals first before it does any other kind of logic here. These are just like functions to use later. So first it just goes ahead and checks the gamepad. Then it toggles all the signals that need to be done for this frame. Then it handles your pointer stuff because this depends on the signal loop being accurate for this frame. So getting all this in the right order here in this function was also kind of a pain, and logicking all that out. And you can see I don't outline my stuff, like everything's just inlined. This has a label because it's needed for the control flow here with continue, but also just because, you know, this could be its own function, right? All of these like big blocks of code can be their own function. I don't code that way though. I compress everything just into one. I like huge, gigantic monolithic functions and monolithic systems in general that just do a lot with like one big struct that has like 200, 500, 1,000 bytes of just fields and variables and stuff going on. That to me just is so much easier than breaking it up into all these 50-line objects, because you need it to be 50 lines or less per function, and use small functions and whatever and object-oriented crap. I don't do anything that way. Anyway, so yeah, I think that's all I wanted to show. I just wanted to kind of show, like, you can have these pretty smooth looking, and you know, I really just like the way that this feels, and I like using the actual mouse cursor as like the pointer, and the fact that this is all like logicked out correctly and there's no bugs as far as I know. It took 2 days to completely, you know, debug it and get it working the way I want it, but it's a really cool input system and way of managing states for, you know, handling the physical hardware. This handles, you know, the keyboard, mouse, gamepads, everything. And just condenses it all down into this one like bit set. It's just this one integer basically, where it has the whole state of what's going on, Are you trying to go confirm on a menu option? It handles the pointer. It handles your. It lets you completely play the game in theory with literally just a controller. If you don't want to play with a mouse, or if this wanted to be released on like a console or something where there is no mouse and keyboard, whatever, it just works. So completely easy to make, really. I mean, this did not take long. You can easily change all these raylib calls, but it only uses like 4 raylib functions anyway, but you can easily change this to fit with whatever platform or whatever system, and you can easily trivially implement more features. Like you could have a use the left joystick as pointer control thing mode, where basically if you move the left joystick, it moves your mouse around. So if you're holding left, it moves the mouse like this. And you can use your joysticks as a way to control a pointer that then interacts with UI elements on the screen. Like you can do a lot with it. It's very customizable, and it's trivial to implement stuff like that. And it animates the cursor, it lerps in between. It's just really nice, I think. I don't know if this is how I want the input system to pan out and how I want it to work in the long term. I don't really know if this is a great idea to have just it moving the mouse for you like that. I don't know. So maybe that will change, but just this basic system and the way it's set up and the API, I think is really great. And you can see here it checks for if you're in manual control mode. So if you're in that pointer control mode, it sets what I call the canonical index. So that's just the retained state of what the user either just pressed or what they're hovering over, etc. So that way, literally, you can check if, if you get a UI confirm signal somewhere else in the code, like not in this file. If you're just doing something at a higher layer somewhere else, you call into this function and you just say, check if this variable is true, if the pointer's on a hitbox. Then you can call, not get hitbox, but get index, I think. Let me see, what's the get canon index. So this just tells you literally what element by index. So this is a two-dimensional thing. It's the x and y of what element the user has either just pressed or whatever, not necessarily pressed, but hovering over or pressed, and then to check if they're pressing it, like pressing the confirm button on an element. This is how you figure out which element they're pressing, and then checking for the UI confirm signal is how you know that they've actually done an action to confirm that menu option. So yeah, and like I said, you feed in this system the hitboxes that you're working with these functions. So buffer hitbox sets up the hitbox that this is how you feed in the hitbox. This is how you set up how many wide and how many things are horizontal and vertical, kind of like a terminal, how many cells wide, how many cells tall you're dealing with. But other than that, this has no interaction. It does not depend on any specific UI system. We don't even use our UI library Clay here. It doesn't need it. It just needs the raylib for setting the mouse is all. That's the only reason we even use raylib. Well, and for reading, the gamepad inputs and stuff. But yeah, I just wanted to show this off. I like systems level, low level stuff like this, and game development, little tricks and neat things you can do, and good abstractions, and not, fake, false prophet, crappy abstractions. It really pisses me off. This is an example of when it's useful to do something like this. It's useful to have an abstraction over physical, dealing with physical hardware values and where the sticks are. That's just messy, and I've done stuff like that before. It's just messy when you work with that. So yeah, and as far as I know right now, this is bug free. I just think this is really cool, just the way it converts from physical input to the abstract idea of what the user is trying to do in reality. But yeah, that's about it.